The B-2 Esprit changed warfare forever, but it was fragile. It needed climate-controlled hangars, endless maintenance, and hours of repair for every flight hours. Now Northrop Grumman and the US Air Force have unveiled its successor, and this time stealth isn't just about hiding, it's about fighting. Welcome to the deep technical analysis of the B-21 Raider, America's first sixth-generation bomber. The paradigm shift durable steels. The B-21's biggest breakthrough isn't a shape, it's a material science revolution. Legacy steels coating were soft, heavy, and easily damaged by rain or friction. The B-21 replaces them with integrated rudder absorbent composite skins, coatings that are thin, durable, and baked directly into the airframe. What does that mean operationally? The B-21 can operate from ordinary hangars, even forward bases, no more steels as a boutique capability. The Raider is built for sortie generation even in harsh weather. Engineers also minimize panel gaps and surface joints. Every edge is aligned to scatter rudder in only a few harmless directions. This is all aspect broad spectrum steels that stays combat ready. Aerodynamic design, simpler, smarter. At first glance, the B-21 looks like a smaller B-2, but the detail matters. First, wingspan, estimated at 132 feet, nearly 40 feet shorter than the B-2. Why smaller? Because a smaller airframe reduces rudder cross-section and fuel burn without sacrificing range. It's an engineering trait, less payload, but far more survivability and efficiency. Second, the trailing edge. The B-2 used a complex W with multiple scalloped sections. The B-21 uses a simpler, cleaner W shape. It reduces the number of angles that reflected rudder and improves high-altitude cruise efficiency. Third, the nose. The beaked or hawk-like nose profile, first tested on the X-47B drone, improves high angle of attack handling and further diffuses incoming rudder waves. No vertical stabilizers, no tails, pure flying wing, the gold standard for low observability. Engine and thermal management. This is where the B-21 hides its secrets. The Raider uses two high bypass turbofan engines, likely derivatives of the F-135 that powers the F-35. But the real engineering is in the installation. Intakes. Deeply recessed serpentine ducts rudder waves enter the intake. Bones long and S-shaped pass, and never see the spinning turbine blades. That kills one of the biggest rudder returns in conventional aircraft. Exhaust. Unlike the B-2, the B-21's nozzles are buried forward of the trailing edge and shaped like chevrons. Hot gas mixes with cool bypass air then exists above the wing surface. Ground-based IR sensors can't see the engine face or the hottest parts of the plane, and there's no visible heat exchanger, suggesting a new generation of internal cooling or even heat-tolerant materials. Result: steels against both radar and infrared seekers. Digital architectures, open systems. The B-21 isn't just a bomber, it's a flying command node. It was designed using digital engineering, every wire, every system modeled before physical assembly, that allowed an open system architecture, or OSA. Here's what OSA means: new sensors, swap them in software, not with saws and soldering irons. Future weapon: the aircraft doesn't need rewriting, just the software updates. The B-21 can carry weapons that don't even exist yet. And on the battlefield, the radar become a JADC2 node, Joint All-Domain Command and Control. It can receive targeting data from F-35s, satellites, or ships, process it on board, and send it to other bombers or missiles, all while remaining completely silent. It's the ultimate sensor shooter link in denied airspace. Operational advantages: because of its aerodynamic efficiency and high bypass engines, the B-21 is officially the most fuel-efficient bomber ever built. That means fewer tanker sorties required per strike package, longer loiter time over targets, hours of silent surveillance waiting for time-sensitive targets, global reach from smaller, more dispersed bases. And because the steel's coating is durable, the B-21 doesn't need a dedicated steel's hangar at every forward location. That's a logistical revolution. The B-21 isn't a smaller B-2. It's a complete rethinking of what it should be: sustainable, adaptable, and connected. The radar brings low observability from the hangar floor to the front line, and that changed everything.